a bit live. Okay, right. So, discussing your open book test organic one, test number one. So the first question, you've got this. This is an example of an organic synthesis. So this organic synthesis is the next topic or the one after polymerization. I don't remember which number, but it's not something that we're going to cover in theory because that's just a combination of all your organic chemistry together to form, starting from a simple starting material to get to synthesize a more complicated organic compound. Okay, so this is what we meant by organic synthesis. Okay, in the first step, you can see that you have attached this group, okay, to the benzene ring. And I'll just talk about the general reaction first, and then we'll answer the questions later, okay? So when you attach that group, if you see the C double bond O is directly attached to the benzene ring, that is an acyl group. Okay, so this is an acylation, right? And then in the next step, you don't know what it is, but you know that you have an additional number of carbons. Okay, use the molecular formula to help you to determine or give you an idea of what is being added there. Okay, so if you count the number of carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You have 13 carbon here, but here you've got 15. So that means 2 carbons have been added. Okay, and you look at the product in step 3. There's 2 carbons being added here. Okay, but now there's a bromine. Here there's no bromine. Okay, so it looks like you have added the 2 carbon, which is an alkyl group, and so it means it's an alkylation. Okay, so the additional group is CH2CH3. If your friend's answer is CH2CH3, accepted. If they answer C2H5, it's wrong because that doesn't give you the structure. Okay? If they give you in skeletal formula, that's the correct answer, or the displayed formula, that's fine, as long as you have got 2 additional carbon. And this reaction is an alkylation. Okay, so that's your Friedel-Crafts acylation, Friedel-Crafts alkylation. Okay, next is the free radical substitution. I give you hints already. Free radical substitution is you substitute the hydrogen. Displayed and skeletal, but it's correct, CH2, CH3. Ada extra apa? Ada extra for carbon, hydrogen. Supposedly tidak ada. So the person added hydrogens in it. Here, just one hydrogen. And then there's no hydrogens in it. Okay, so that's like an incomplete structure, but it's still correct, CH2, CH3, okay, just missing hydrogen. You can add on the hydrogen for your friend. Okay, so any other question? All right, okay. Step 3, you substitute one of the hydrogen with a bromine, and we'll talk about the condition later. Step 4, again, structure you don't have any hints at all. But if you look at the product here with your final product ketoprofen, the additional group is COOH. Yeah? because this C2H5 is the same. So the only thing that you've added is COOH, but you cannot add COOH or substitute bromine with a COOH yet. There is, it's not an intermediate, but like there's one step before you transform this additional carbon to COOH. So the fact that you are adding carbon here, what's one reaction that you can add in order to extend the carbon length by 1 unit? Does anyone remember? Addition of, anyone in your answer or your friend's answer, ada yang tambah satu carbon, additional carbon. Ada? Danish? You seem to nod your head. What did your friend write? Huh? OH. Okay. OH is a good try, but you're not adding carbon. Okay. One way of adding additional 1 carbon is cyanide ion. Did any of your friends answer the addition of cyanide ion? Ada? Ada? Huh? Dipadamnya. Sayang. You. Okay, so if you see there's an additional 1 carbon, that means you are adding the cyanide, CN. Okay, so the structure of U is just that CN, and CN can substitute bromine in a nucleophilic substitution. So that's your AS stuff. Okay, so step 5 is less common, but they like to ask you this question because it's not something that students always remember. You convert your cyanide group to COOH in a reaction called hydrolysis. Okay, the hydrolysis of cyanide ion, and this is one of the ways to produce carboxylic acid that you have learned in AS. Okay, so let's have a look at the reagents and conditions for step 1. C6H5COCl plus AlCl3. Since that is a Friedel-Crafts A solution, you need the C double bond O to be attached to a chlorine, and you use an aluminum chloride catalyst. Okay. For step 2, you want to attach the CH2CH3 or your ethyl group. It needs to be attached to a chlorine as well, and AlCl3 as your catalyst because it's a Friedel-Crafts alkylation. Step 3 is a free radical substitution. You need bromine and UV light. Heat is also accepted. Okay, if your friend wrote down heat, you should accept the answer. Step 4 is potassium cyanide or sodium cyanide in ethanol. This is your AS stuff, plus heat. Okay, if your friend answered KCN in aqueous, it is wrong. Okay, KCN aqueous is wrong. If your friend answered CN minus ethanol, I would accept, as long as there's the cyanide ion there. Step 5, I've already given you the answer. H plus in H2O and heat. Okay, so there's 4 marks for part B. For part A, there's 2 marks, 1 mark for each correct structure. Please make sure you give your friends marks as well. Okay. Types of reactions. Step 1. It's not the acylation is not a type of reaction. That's just the simplest way of seeing a reaction. But when they ask you for the type of reaction, you will write down the full mechanism. It's electrophilic substitution. And as mentioned just now, step 5 is hydrolysis. Do you see any other answer? Step 1, they accept nucleophilic substitution, but I prefer electrophilic substitution. Step 5, another accepted answer is nucleophilic substitution, but I prefer hydrolysis. Okay, if your friend answer any of this, you can give them 1 mark per reaction. Okay, moving on. Okay, since we're running out of time, we'll just go straight to the answers. To B, part 1, describe the conditions that are used to ensure substitution takes place only in the aromatic ring. In the aromatic ring, we're looking at substitution, nucleophilic substitution. So you need a catalyst, which would be AlCl3 or FeCl3. Okay? Why do we use only the chlorine halogen carrier or the catalyst? Because you are adding chlorine to the molecule. Substitution. You substitute one of the hydrogen in the molecule with chlorine. Describe the conditions that are used to ensure substitution takes place only in the side chain. Side chain is here, it's an alkane. So the reaction for alkane is free radical substitution. You need sunlight or UV light. That's all for 1 mark. Draw the structures of the 2 isomeric products. So the 2 isomeric products are here. You attach chlorine on that first carbon. The other one is you attach chlorine on this carbon. Okay, so I'll just number the carbon. That's carbon 7, that's carbon 8. This is carbon 7 and carbon 8. Why have I called it carbon 7? Because carbon 1 to 6 is inside the ring. Okay? So make sure that your friend draw the chlorine on carbon 7 and the other one on carbon 8. If they draw it on the other side, for example here, that's also okay, right? That's considered carbon 8. It's the same thing. Either you draw on the left side or on the right side. If your friend add the chlorine onto the ring, anywhere on the ring, it's wrong because the question says takes place in the side chain. Okay? So that for 2 structures, you get 1 mark. If your friend only gave you 1 structure, that's 0. Okay, that's the thing about A level, there's no half marks. If only 1 out of 2 structures are correct, then there's no 1 mark. It's automatically 0. So total for this page, 3 marks. Okay. For part C, okay, I'll just quickly write down the answer. You should get a benzene ring with a COOH, whether they write down or draw out the structure, that's fine. That is the oxidation. Next is the hydrogenation. Oops, sorry. Hydrogenation, all single bonds. You should not have the ring structure in the benzene. Okay? So 1 mark for each structure. Okay, last one. 4 marks for the mechanism. I'll just go really quickly. It doesn't matter where your friends put their NO2. But the first mark is for writing down NO2 plus. If you see NO2 plus anywhere on your friend's paper, then that's correct. The second mark is for an arrow coming from the ring to the nitrogen. That's your second mark for your friend. The third mark is for drawing the correct intermediate, keeping your alkyl side chain the same. Okay, make sure your friend don't leave that out. So I'm just going to write down my NO2 here, and I have a broken delocalization. If your friend has this correct intermediate, that's the third mark. The fourth mark is for drawing out the carbon-hydrogen bond, and the arrow from the carbon-hydrogen bond back to the ring is the fourth mark. Okay? So in total, for this page, there are 6 marks. All right? Okay, so can you please just sign your initial or your signature on the last page of your friend's paper, and then I will check your friend's paper and will return it to you tomorrow. Okay? So that is all for today. You can go now. NO2H. So artinya the fourth mark nada. Yeah. So total is section missing. That's right. Um, okay, so I need 2 words. Yeah, 2 marks only. Okay. Ani, yeah, this one. Okay. Please give me your friend's papers. I will have a look at them and then I'll return it back to you tomorrow.